Factoring trinomials. In order to begin factoring trinomials, let's dissect the multiplication of two binomials using the FOIL method. As you recall, the FOIL method means that we're taking two binomials and multiplying the first terms, the outside terms, the inside terms, and the last terms in order to ensure that everything in the first set of parentheses multiplies everything in the second set of parentheses. We get 4 terms when we do that, and collecting like terms, I get this middle term of 8x for this set of binomials. So looking in this process in reverse, we want to figure out how it is that we arrived at the trinomial's first term. The first term was the product of the first terms of each of the binomials. The second term is the product of the outside added to the product of the inside. And the third term, or our last, multiplied together, gives us the 15. So how do we arrive at this trinomial's first term? The same way, we get a 6x squared splitting this way. 11x outside and inside, and the 4 they've split up as 1 and 4. Is this placement unique when we have a trinomial that's factored this way? Well, let's see. If I had put instead a 2x plus 4 and a 3x plus 1, switching the place of my last terms, what would we get? We have a 2x times 3x is 6x squared. We have the outside is a 2x. We have the inside is a 12x. And the last is a 4. So when I collect my like terms, I have 6x squared plus 14x plus 4. And this is not what our trinomial was, so definitely the placement is unique. Why or why not? Well, we tried out moving those terms and it didn't end up to be the same trinomial. So this is the factorization for this trinomial. The same terms in the binomials, but in a different order, is going to produce a different trinomial for us. So how do we arrive at this trinomial's first term? Again, it's the product of the first. The second term is the outside and the inside added together. The third term is the last multiplied together. So here we have different signs. Is the sign placement unique? In other words, if I had a 5x and put the plus here and a 3x and put the minus here instead, would I come up with the same trinomial? Well, 5x times 3x is 15x squared. I have a negative 35x. I have a positive 6x. And I have a negative 14. When I combine like terms, I'll have 15x squared, negative 29x, and a negative 14. So the first and the last are the same, but I don't have the same for the middle. I have the same number, but not the same sign. So this is a different factorization for a different trinomial. So the sign placement definitely is unique. Here, if we have the factors in the same place, but we switch the signs, we'll get the same middle term, but a different sign, which means it's a different trinomial. How do we arrive at this trinomial's first term? Again, the first term comes from multiplying the first. The second term from the outside and then the inside, and then add them together. And then the last from multiplying those. So are there some combinations of factors that we could eliminate as a possibility? Apparently we're splitting 10x squared up as 2x and 5x. What if we had split it up instead as x and 10x? That would give us a 10x squared also, wouldn't it? So let's go ahead and try. If I make this an x minus 3 and a 10x minus 8, is this a possibility? If I multiply, I get my 10x squared for the first term. For the last, I get my positive 24. And for my middle, I'll have a negative 8x and a negative 30x in the middle. So when I add those together, I get a negative 38x, not what I wanted. So this is not the factorization of that trinomial. Now if we look at the trinomial that this factorization created, you'll notice something interesting. We have a common factor of 2. We don't have a greatest common factor here. So this is definitely not a factorization that we would consider viable. Also, if you look at this, there's a greatest common factor in this one factor. If there's not a greatest common factor in our original trinomial, there's not going to be a greatest common factor in one of our factors. So definitely, because of that reason, we would not even consider this factorization as a possibility. Let's say that we keep the 2x and the 5x split this way. And let's say both of our signs are still negative, but we split 24 up instead of 3 and 8 as 4 and 6. 4 times 6 is my 24, so that would be fine. But again, I have a greatest common factor in this one factor, so I would not consider that a possibility. I could also put a 2x minus 8 and a 5x minus 3. My first term would be the same, my last term would be the same, but again, I have a greatest common factor in one of my factors, so this is not a possibility. There are lots of ways that you can eliminate possibilities when you're looking at greatest common factor. So while we're using the guess and check method of factoring, there are some smart ways of guessing and eliminating some combinations before we ever try them. This would speed things up. The first thing is that you need to make sure to factor out any greatest common factors for the polynomials. This will make the factoring process less painful. Next, determine whether your signs will both be positive, both negative, or one positive and one negative. Third, when you're building your possible factors, you should not have a common factor within one of the factors. Don't waste your time trying these types of factors. If you have already factored out the greatest common factor for the entire polynomial, you will not have another greatest common factor within your factors. Likewise, if you didn't have a greatest common factor for the polynomial at all, you still will not have a greatest common factor within one of your factors. Let's practice factoring some trinomials. Now, if something cannot be factored, we'll just write it as prime, meaning it cannot be factored. So here I have to break up. I know I'll have two binomials, and I'm going to split up my x squared as x and x. I'm going to split up my 2 as 2 and 1. What will my signs be? Well, I don't have any negative signs, so really I don't need to worry about negative signs. But let's look a little closer. Here I have a positive. All that tells us is that these signs will either both be positive or both be negative. We cannot have one positive and one negative, because if we had a positive and a negative, that would have multiplied to be a negative 2. If we have a positive times a positive, it's a positive 2. If we have a negative times a negative, it's a negative 2. So here we know that we must have both the same signs. When we look at the middle sign, it tells us what sign they will be. It's going to be a positive. Let's go over here and check. Now, I know that I have split that up so that it becomes that. I know I've split that up so that it becomes that. What I need to do is just check the middle term. So when I'm checking x plus 2 and x plus 1, we can go outside, inside. That gives us an x and a 2x, which adds up to be my 3x, which is what I need. So I know this factorization is correct for this trinomial. Let's try factoring this trinomial. The first thing that we notice is that there is a greatest common factor. Let's take that out so this will be a little easier for us. My greatest common factor is a 3a. Once I take that out, my trinomial is a squared plus 7a plus 6. Now I need to carry down that 3a. It's a monomial factor, but it needs to stay along with the rest of my factorization. I'm going to split my a squared up as a and a. Now I'm looking at 6. There's more than one way to break that up. We could write it as 2 and 3 or 1 and 6. Which one would work? Well, if you're not sure, let's go ahead and try. A 2 and a 3. So that gives me a 3a and a 2a adds together to be 5a, and that's not what we need. So let's go ahead and split it up the other way. 6 and 1. That gives me a 1a, and 6a is 7a. So I know this is the factorization of that trinomial. Let's try factoring this trinomial. I'm going to go ahead and start with parentheses because I don't have a greatest common factor. 5x squared can only be broken up as 5x into x. 2 can only be broken up as 2 and 1. Now it might not be 2 and 1 here, it might be 1 and 2. But let's just go ahead and try something. Now I have a positive here, which means my signs are both going to be the same. The negative here tells me that they'll both be negative then. Let's go ahead and check the middle. A negative 5x and a negative 2x is negative 7x. And that's not what we need. So let's switch our factors. Let's put the 1 here and the 2 here instead. This gives me a negative 10x and a negative 1x is negative 11x. I've successfully factored that trinomial. On this trinomial, we'll go right to our parentheses because we don't have a greatest common factor. We'll split z squared up as z and z. I know that this is a plus sign, which means both signs will be the same. This plus means they'll be positive. My 7 can only be broken up as 7 and 1. If I check the outside and the inside, that's a z, and a 7z is 8z. That's not what I need. And it doesn't matter if I put a 1 here and a 7 here because my z's are the same. So basically, we cannot factor this polynomial. It's going to be prime for us. 15r squared plus r minus 6. We don't have a greatest common factor, so let's dive into factoring with the parentheses. And we can break up 15r squared. There are a couple of ways we could do it. We could go with r and 15r. We could go with 3r and 5r. My rule of thumb is that if this middle is not a large number, then you want to pick factors of these terms to put here and here that are closer together rather than further apart. 1 and 15 are pretty far apart on the number line as opposed to 3 and 5. They're a lot closer. So I'm going to put a 3r and a 5r. Now with 6, I could break that up as 6 times 1 or 3 times 2. I wouldn't want to, if I did 6 times 1, I wouldn't want to put a 6 here because that gives me a greatest common factor. So I would have to go a 1 and a 6. So let's see, a minus sign just means my signs are going to be different signs. I'm not sure if the placement is correct, but we're just going to put them down so we can try it. So let's check the middle. We have a 18R and a minus 5R is not an R. So we know that we can't have the 6 here, and we also know that we can't have the 1 there either. So let's try breaking up 6 as 2 times 3. I don't want to put the 3 here because I'd have a greatest common factor. So the only way I can break that up is 2 and 3. Now let's check our middle. This is a 9R, and a negative 10R is a negative R. So we get the right number but the wrong sign. So what I have to do is just go back and change the signs. Make this a positive and this a negative instead. So I have a negative 9R and a positive 10R is a positive 1R. 3 minus 4x plus x squared. If you want, you can rearrange this. The x squared is still positive, and the negative 4x is next, and my positive 3 is last. When I go to factor this, then I have an x and an x. My 3 can only be split up as 3 and 1. And my signs are going to both be negative. Because I have a positive here, it simply means the signs will be the same, and the negative tells us they'll both be negative. Now when I check this, I have a negative x, and a negative 3x is negative 4x. So I know I have factored that correctly. X squared minus 6x plus 5. Here, we'll break up. Again, we don't have any greatest common factors, so we're simply going to break up the x, and 5 is 5 and 1. We have 2 negative signs because the positive here means the signs will be the same. The negative tells us what the sign will be. Let's check the middle. We get a negative x, and a negative 5x is negative 6x. So I know that I have this factored correctly. 3t squared minus 7t minus 6. I don't have a greatest common factor, so I'll jump right into splitting up my terms here. I have a 3t squared can only be broken up as 3t and t. My 6 can be a 6 times 1 or a 2 times 3. If I did 6 and 1, I would not want to put the 6 here because I'd have a greatest common factor there. But I could try 1 and 6. My negative sign here tells me that my signs will be different signs. I have a negative 18 plus 1 is not a negative 7t, so I know that I can't have that. So I've exhausted the possibilities of 6 and 1. Let's try 2 and 3. I would not put a 3 here because I would have a greatest common factor of 3 in that first factor. So this would have to be a 2, and this will have to be a 3. Now let's check the middle. Negative 9t plus 2t is negative 7t. So I know I have that factored correctly this time. Let's write a polynomial in factored form that represents the total area of this figure. If we're looking at this first part, the 2x squared, what made the area of that rectangle a 2x squared? We could say that this was x and this was twice x. You notice that this we could interpret as twice the length of this one. So that makes sense. So if this is a 2x and this is a 2x, then that must mean that this side is a 3, because 2x times 3 is 6x. Over here I have just an x. I know that this length was x, so this length must be 1. And this is a 3, 1 times 3. Looks like we have it. So if we look at the factorization here, this is a 2x and a positive 1, so it must be 2x plus 1. And this 1 must be an x and a positive 3, so x plus 3. So this is the polynomial in factored form that represents the total area of this figure. That covers this section, so go ahead and try your homework. Be sure and let me know if you have any questions.